Okay, set up your next page. Oh, wait, there's nothing to set up. So get a new page on here. And in this case, what we're going to be talking about are phase changes. So, and I'm going to turn my paper sideways like this because it makes me happy. So phase changes. And I'm going to take about a fourth of the page and I'm going to block it off right over here.
Are you doing it narrowly, like this way? Or
Okay. So I have my phase changes. And again, most of this stuff you already know, so it'll be a review, but there'll be some that's new to you guys on here. So you'll have to kind of decide, well, what is it I need to study on this? So the number one thing that you're going to have to stick in your brain is whether or not phase change is endothermic or exothermic. So the first two I'm going to put together, I'm going to put melting and freezing. Obviously, they are opposites of each other, right? Melting and freezing. And when we talk about this, we say melting point, MP, and freezing point, FP. So melting point, I'm just going to put that one there. You can figure out what the freezing point is. Phase changes are created by changing the temperature and the pressure. Okay, we create the phase changes by changing the temperature and the pressure. If it's a high pressure and low temperature, we typically have a solid. And if it's a low pressure and a high temperature, we typically have a gas. Obviously, that's in general what you can think of, right? And then the liquids are somewhere in between there. Now, when we say high temperature, that could be, if you're talking, depends on what your substance is talking about, maybe a high temperature for nitrogen, where it's still a gas, is, negative something degrees Celsius. But in general, if it's high pressure, low temperature, and we talk about a solid. And if it's high pressure, low pressure and high temperature, we talk about a gas. So the first two are melting and freezing. In order to get ice, and always, 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 you guys need to think of water, because you have firsthand physical, actual experience with water. To get ice to melt, do you have to put energy into it or take energy away from it? Think about that a minute. I got one. Yeah, you have to put energy into it. So if you put energy into it, it is endothermic.
I have a question.
So melting is an endothermic process. Yes.
You know over there when you put the arrow and a pressure?
Uh-huh.
Did you forget the T?
Oh, I did. Yeah. There's a T right there. Okay, stop and think about that a minute. Melting is endothermic. You have to put heat in, right? Okay? That means freezing, the opposite of that, don't you have to get rid of heat? So it's exothermic. A lot of times, this is where people fail. A lot of times we think exothermic and we only think, hey, it's giving heat off, I can feel it. You can feel it, whether or not you can feel it is insignificant. It has to give heat off. If you take water and you want it to freeze, you have to take energy away from it. You have to take these molecules that are going like crazy in a liquid form and you have to slow them down and get them to stop. You have to take the energy away from it, right? Where does that energy go? It leaves the system. That's what makes it exothermic. So you need to delete from your brain that exothermic has to give off heat that you can feel. You're obviously not going to be able to feel heat coming off of the water getting colder, are you? Yeah, it's not going to work that way at all. So think of freezing as exothermic, but don't get stuck on exothermic as being, hey, it's got to be a fire, it's giving off heat like that. It doesn't work like that at all. The next two are vaporizing and condensing. Okay, generally when we talk about this, we talk about the boiling point. Okay, When a liquid changes to gas, is that endothermic or exothermic? Do you have to give it energy to take that water and change it to a gas? Do you have to give it energy or take it away? Mm-hmm. How do you get water to change to a gas? Don't you have to boil it? Yeah, you heat it up. So when you give it energy, energy is put into the system. That's endothermic. Think about this. You have liquid water, right? And it's going to have to be separated and go crazy like this. You have to give it energy to do that. When you put energy into the system, it's endothermic. That means the opposite of that is going to be exothermic, condensing. So now you have this gaseous water, and you want to bring it down, cool it down, so now it's closer together and moving slower. That's going to be exothermic. It has to dump all the excess energy that it has. You've got to get rid of it. That's when that heat leaves the system, that's going to be exothermic. Yep. The next ones are the weird ones, sublimating and, sorry, I wrote condensing, and it should be depositing. Where's my stuff? Do you guys have that? Give me that white out. Depositing is the other word. And when you have sublimating, and I'm just going to put this, it's a solid straight to a gas, and then this is a gas straight down to a solid. It skips the liquid phase. That's what they are here. So when it sublimates, it goes from a solid to a gas. To get something to change up to a gas, do we have to input energy? Yes, that means it's going to be endothermic. It takes in the energy. And the opposite of that, changing it back down from a gas to a solid, has to be exothermic. So you have to take how it feels to you out of the equation. It's not a matter of how it feels to your touch. Your hands are the poorest type of temperature thermometers, I guess you could say, possible, because we could all touch the desk, and some of you guys are going to say, oh, it's cold, and some of you guys say, no, it's warm. You know, it just depends on how cold your hands are, right? It depends on you. So using your hands as a heat or cold sensor, a thermometer in that sense, is totally worthless. Okay, now what I'm going to show you now is I'm going to write this, and I want you guys to write this up here too. SLG. I want you to write it like this. SLG. As it goes down from a gas to a liquid or a solid, it's got to be exothermic. As you go up, changing from a solid to a liquid to a gas, that's going to be endothermic. And what I'm going to tell you now, and I'm going to add this in here, as you go up, you increase the chaos or entropy. It's called delta S. Because think about it. Here's a solid, and then it gets a little crazier when it changes to a liquid. And then it goes absolutely insane when it goes up to a gas, right? Chaos, entropy increases. That's what delta S is. As you go back down the other way, we have a negative delta S, because here you have all this chaos and disorder with the gas, and you bring order to it. You bring it back down. You bring it where it's more orderly. And so the chaos, the disorder is what it's truly called, decreases as you go down. So the next thing we're going to talk about is energy. Okay, once you've written that down, let's go ahead and pack it up for the day.